Hi, I'm Zehui. I'm going to introduce our work. The title is Intentional Head Motion Assisted Locomotion for Reducing Cybersickness. Cybersickness is often a problem in many VR applications and also a critical obstacle for users who have a good VR experience. The goal of our work is to reduce cybersickness by controlling the locomotion using the head. There has been a lot of research on cybersickness, including some works on the cause of the cybersickness. Among them, most widely accepted theory is the sensory conflict theory. It explains that the users would feel sick if the perceived information from different senses conflict with each other or conflict with the user's expectation. One important source of conflict is the conflict between the visual and vestibular perception. For example, when using the popular joystick-based steering locomotion method, your wheel moves smoothly while your head is stationary. You will have visually self-motion illusion, but your vestibular perception suggests that you are not moving, so you may feel sick. Another widely used locomotion method, called the teleportation, is performed by pointing to a desired location and directly moving to the location. This method brings nearly no visually self-motion illusion, because the wheel suddenly changes and does not move smoothly. However, this will also breaks the feeling of immersion, so teleportation was reported to have lower presence than the joystick-based steering. We propose a novel locomotion technique with the assistance of intentional head motion, which yields low cybersickness while maintaining a high presence. We reveal some relations between translation angular velocity and cybersickness through user studies of cybersickness, and they all present a possible U-shaped relation. We validate our method's effectiveness through user studies, and the results demonstrate that our methods can be a feasible locomotion solution to VR applications using the commercially available head-mounted device suite only. Our location method is inspired by the sensory conflict theory that we can reduce cybersickness by giving similar feelings of motion. Motion perception can be decomposed into direction and magnitude. For translation, we have a translational direction and a translational velocity. For rotation, we also have a rotational axis and an angular velocity. We assume that people are more sensitive to the conflict of direction. Therefore, we design a head motion assisted location and try to invoke a matching visual and vestibular perception, which should reduce the conflict. More specifically, the users hold a button and move the head, and the virtual camera will also move in the same direction but in a faster velocity. Users can move forward, backward, left, and right. And rotation is similar. Hold the button, rotate the head to invoke a faster rotation. Since the wheel still moves smoothly in our method, we expect it to retain a high level of immersion. A field research investigated the correlation between cybersickness and locomotion velocity. The studies generally conclude that faster motion induces stronger cybersickness, and some studies reported that when the speed is too fast, cybersickness seems to decrease. We also conduct an experiment to study how much the velocity of translation affects cybersickness after the virtual direction matched the head motion direction. In the eco-exposure task, we have 35 participants. They are asked to navigate freely in an urban scene. They are asked to collect green balls as many as possible in 7 minutes. The results show that there is no significant difference on the total score of sickness on all 5 velocities, which is different from the common view. This may suggest that the magnitude of translation has little impact on cyber sickness in our method. We also conduct an experiment on rotation magnitude. We have 40 participants. They are asked to rotate to random numbers from 1 to 12 in 3 minutes. The results indicate that the total score of cybersickness at 90 degrees per second is significantly lower than that of 30 degrees per second, which is also different from previous works. It is surprising that the sickness scores of our method is so low. One may expect that the task is not sufficient to induce sickness within a limited time. Therefore, we conduct an additional sub-experiment involving 11 new participants. They are asked to finish the same task using joystick-based steering rotation with less exposure, around 2.5 minutes. The results show that joystick-based steering rotation causes much more severe cybersickness, around 1 magnitude larger on the total score. Statistical test also shows that the sickness by our method is significantly different from the joystick-based steering rotation on all 5 angular velocities. Finally, we conduct an experiment to compare our method with the commonly used joystick-based steering and the teleportation method. We have 51 participants, and they are asked to follow the guiding path in an outdoor urban scene and an indoor scene. The results show that our method has significantly lower sickness compared to joystick-based steering. Although the sickness score of our method is higher than teleportation, the scores do not have statistical significance. And for presence, our method has significantly higher spatial presence and experience realism compared to teleportation. So we present an intentional head motion assisted locomotion method. The user studies indicate that our method has less cybersickness than joystick-based steering, while achieving a high level of presence. So our method is a feasible option to navigate in VR applications. But to use our locomotion method proficiently, the user must generally have a good physical movement and coordination skills between the human hand, head, and body. This is a limitation and may lower the usability of our method. And in its current state, the underlying rationale still needs to be further explored and verified by experiments. Regarding the motion perception mismatch, we only consider the direction and magnitude of velocity. There may be some other factors like latency of frames per second. This needs further study. So the presentation is over. This is the reference list for these slides. Thank you.